Okie dokie. Tutorial number 3, guys. We've now moved on to chapter 2. We are looking at vectors in a plane, and we have jumped all the way to the 2.7 review exam practice. And we're just going to work our way through our simple familiars. So, question 1. Can I get one of you guys to read it out to me so I can stop going back to my laptop?
If vector A equals 4i take 3j,
4i take 3j,
and vector B equals 2i take 4j,
2i, 4j,
then evaluate without technology for vector A take away 2.5 vector B.
4a take 2.5b. Okay, good little warm-up question because it requires you to do 2 skills. The first one is scalar multiplication. The second one is the subtraction of 2 vectors. Okie dokie. So let's start with our little 4a. To do 4a, I think as Britt was setting up earlier, you just chuck your 4 outside of vector A. So you've got 4 outside of it. Yeah, can you guys just let them in? While we're here, let's do them all, and that's going to be subtract 2.5 times everything in vector B, which is your 2i and your 4j. What's your answer for this one, Britt?
That was 16i take 12j.
Sounds pretty reasonable to me. I'm going to keep mine in brackets just for now. Have you done your other one? What do you get here?
Yeah, 5i take 10j.
It should be plus.
I'm going to leave mine like this right now. I'm going to leave my subtraction out here, and I'm just going to follow it through, but I do take your meaning. So that gets you your 5. Your 2.5 times the 4 is going to be a subtract 10. Okay.
So
now,
did you forget your I for 16 in your first bracket?
thank you. Chuck my I back in because we can't get rid of it. So what Indy's saying, guys, is the same thing that we've just learnt with our complex numbers. To subtract 2 vectors, often the way you want to think about it, keeping your brackets in place, minus 12j, is what you want to actually do is add the reciprocal or the opposite of that one. Okay, so this was a positive 5. This is now negative 5i. This was negative 10. It becomes plus 10. The main reason that we're doing this one is that if I drop these brackets, which is a lot of you would probably have written, you would have subtracted the 5, and then you would have subtracted 10. Because you forget that that negative applies to the entire vector, both the I and the j components. So that's the main reason we do a plus and swap them here, just so that you don't make that mistake. 16 minus 5 is 11i. Negative 12 plus 10 is negative 2. Quick note, because I've already checked it, your textbook here is wrong. Okay, your textbook tells you that's 22j. They originally, when I went back to see where they went wrong, they wrote their B vector with a plus 4j. So just if you're either watching the video, people at home, or if you guys are checking your notes, that is why question 1 is wrong in your textbooks, because they had 2i plus 4j. Okay, but again, just expanding brackets, so it's the same scalar multiplication that we've been doing with complex numbers, and then we add and subtract vectors and complex just the same. So what you're learning currently in class should help you with your revision of vectors. And it's the same, was it you, Britt, the other day? You had that one vector question in there?
No,
I was like, what the hell do? You do it exactly the same as the complex, and that's why they slipped it in the middle of the complex chapter to make that connection. Yep. Okay. Word question, what do we want to do?
Draw a picture.
Draw a diagram. What does it tell me? I'm starting somewhere and I go...
Start at H.
Where do I go?
5 kilometers due east.
Which way's east?
Left.
Right.
All right.
5 kilometres due east. Then what do I do?
Northward at a bearing of 45 degrees.
So what does that mean? Northward
Means
is
that
bearing of...
where your new position is, you're changing your degrees by 45 to the north.
So I'm going to the north. So is this my 45 here? Is that what you mean? I've gone 45 up from the horizontal?
No, so you're turned north and then you're going 45 degrees off your north. So the 45 should be on the top of the vector there.
So you're saying that this would be 45 degrees here?
Correct.
To north?
Yep.
Would it have made a difference?
Oh, yeah, probably not.
45 degrees? Just checking to see if you knew which one was which, because in this case it wouldn't have mattered if you'd had 45 underneath or on top. Okay, because you end up the same. But it is important to know. I think the next line in that is actually tell you that it's north 45 east. So you are correct. You would go from north 45 degrees to the east. So technically it's that bearing there from true north and not this underneath one. So for this question it wouldn't matter. For other ones it could be important if you said the top angle was say 30 and the bottom was 60, or if you had them the other way around. Yep, so on that question it actually gives you a second line. Turns northward at a bearing of 45 and then in brackets north 45 east. So that's what would help you determine it's definitely from north 45 degrees in the easterly direction. Yep, and that would be your 45 degrees.
It goes for 10 kilometres in that direction.
Thank you. It goes for 10 Ks.
And then due north 5 kilometres to X.
And then from here, due north 5 kilometres, and we call this point X. Okay. Then I'm assuming the question is going to be calculate this. Would that be correct?
Yeah.
Calculate from H to
Calculate from H to X.
the position vector.
The position vector. Yep. What's a position vector?
Your I and J component.
And that's different to what kind of vector?
A line.
Polar form? What's polar form?
Is that I and J perhaps?
No, that's our position vector, our Cartesian form. Polar.
Oh,
It's another way we could write a vector. If not, it's I and J component. What do all vectors have?
Direction,
And,
a magnitude.
yeah, so we can write it by its magnitude and its direction. So instead of its x and y, we calculate its hypotenuse, and we also know its direction. And we have the exact same information.
How would you calculate your hypotenuse off that? Would you just add them, all those?
Well, this isn't a triangle.
Let's make that very clear. This is not.
This is not a triangle. So we're not actually calculating hypotenuse. Here we're going to do vector addition. We're going to do it with 3 vectors.
If
So
you
what do we
were
do for vector addition?
H to, we'll call it point A, point B. So from point A, from H to A, then plus A to.
Can I slow you down for 1 sec? Before we add vectors, would it be a good idea to have some vectors?
So would you find your, not your hypotenuse, your
Yeah.
adjacent and your opposite for your 10Ks, and then you can go your 5Ks plus whatever that answer is. It's your I components, and then your 5Ks north, and then whatever your opposite of your 10Ks, that would be your Y.
Yeah, so that is what we are going to do, Britt. What I'm asking you all is to just slow your roll, break it down. Before we can add vectors, let's write some vectors. So let's just call this first guy H. How would I write vector H in its position format or in its Cartesian form?
It would be 5i and 0j.
Correct. Okay, it has a 5 units on the I axis, it has 0 units on the J, no vertical component. We're going to call that last guy X because that's where we finished, so let's just call this middle vector A. How would you write the I and J components for vector A?
You'd find your adjacent and hypotenuse of that. Due because you know it's 45 degrees due north, so then obviously that along the horizontal, the horizontal, it's 45 degrees as well. So then you just do,
45.
yeah, 45.
How long was this again? Sorry, oh, this was 10 Ks. Hey, I'll write it up here so we make sure it's in the right place. So you guys are right. There's a really simple way that we write this in vectors though. Something that we know about having our magnitude. So it seems like maybe you've forgotten. I will just get it in for you. So here's your 45. So what are you telling me I is on this triangle compared to your angle?
Can you say that again? Sorry, sir.
What is your I component of this triangle? Hypotenuse, adjacent.
You're adjacent.
Oh, adjacent.
It's your adjacent, okay? So this is your adjacent. I know the hypotenuse. You guys have done trig enough now that you should just be able to rearrange that to say that 10 times cos 45 will be your I component. Because this is the trigonomic part of the thing that's going to get you this value. how long is it? Because that's what you were telling me to do, Britt. I'm just showing you that you can actually just write it straight in your vector. So your magnitude times cos of the angle plus, what do you think my j component's going to be?
Sin.
10 sin 45j. That's the fastest, easiest way to write that one.
Would you then calculate that or just leave it as that?
I'd leave it as that at this point. And the reason for that is that some things cancel out and simplify down. And so you want to leave, like if you're going to get decimals, like if you plug that in and get a whole number, just use that whole number from now on. What you'll often find in this textbook, because we're more interested in the processes, we do get nice whole round numbers. And when we don't, they always leave it as that. They don't like to write it as 27.36489. They leave it as some random root, or as a fraction, or they might just leave it as 10 sine 15. What's my x vector? Yep.
Zero.
Would it be 10 sine 45j plus? Yeah.
This guy, just from here to here.
It'd be 0. I wouldn't. So
Yeah. We have no horizontal component, and we have 5 for the j. So your first two vectors are really easy. A horizontal line has no j component, and a vertical line has no I component. So we've got that guy and that guy. So now if we want to do vector addition, so I will come over here and let's go h plus a plus x is going to be equal to 5i. Now there's no point in writing plus 0j, so that's just going to disappear from my equation. 5i plus 50 cos
would you put those
45.
in brackets for your different vectors?
You could, if that helps you want to break it up. That's the start of your second one. That's 10 sine 45j. And then finally plus in your last one. Again, it doesn't have an I component, so you just write it's 5j. So you could have done it earlier, Lachlan, or now would certainly be a time. I'm trying to get something out of it. On the camera, which I just did. That'll be a fun little bit for everybody watching at home. You can still see all the important things. Oh, it's going to do my head in if it's not exactly the same. So we have 10 cos 45. So I'm collecting my i's now. That's 5 plus 7.07i. Everything's positive. And then I'm going to have 5 plus, I'm pretty sure the sign actually comes out to be the exact same thing. With some rounding, 7.07j, 12.07i plus 12.07j. And that would be the position vector for h2x. Again, guys, I think if you're checking this at home, you'll find that they had 5 plus cos 1045. I'm not sure that they actually calculated those values, but just letting you know. If you're checking against the answers as well as what I'm doing, you might find some slight differences. Questions, problems, queries before I start loading up the next one? I know. That would be the next one. My battery might have just died. That's okay. Somebody can tell me what part B is. I'm assuming it's to tell me the magnitude. Would that be correct?
Calculate the distance from h to x.
Calculating the distance from h to x. Okay, so another way that we could have written this is the vector h to x. So now we are going to calculate the magnitude of h to x. How do we calculate the magnitude? What's that? Addition? Comes back to Pythag, guys. I component, j component, what's the magnitude? So if this is the number on your I and this is the number on your j, then your magnitude is going to be the exact same as your Pythag rule. A squared plus b squared, find the root. So in this case, we're doing root 12.07 squared plus 12.07 squared. And when you take the root of that, you're going to get 17 and change. I'm going to read mine as 07 kilometres. Does the question tell you to just do it to the nearest kilometre?
Correct to 2 decimal places.
2 decimal places. 1707.
Does it need to have an I and J component, so no?
Magnitude does not. No, remember, your I component think of as your x or your horizontal, your j you think of as your vertical, and the magnitude is the hypotenuse. Has no I or j, it has a value. Scalar number, how long is that line basically? How long is that line? My computer's back awake, so if there's no other questions on that one, we can have a look at 3. All right, I believe 3 to be an angle question.
Yep.
Calculate the angle between A. Somebody read it out to me.
Vector A equals 3i minus 2j.
And vector B.
16i plus 24j.
Plus 24j. Hockey docky. Anybody remember an angle rule that we might want to use? This one doesn't come back straight to trigonometry. You can if you break down all the parts, but we have shown you a rule, and I believe you'll get it in your formula book. Double check with Mr. G. Angle between rule is in their data booklet.
They'll get both the product rules, they just have to combine.
Okay, you'll get both dot product rules, you have to combine them. Okay, we can talk about that. We might do that one in class. For now, let's just apply them.
Oh yeah, I remember.
Yeah, yeah, now you're starting to remember. Alright. Okay, so, Mr. G's a bit of fun.
You did it wrong.
Oh, sorry, I got my squiggles on the wrong ones. Let's be perfect and precise, guys. You guys know I'm talking about vectors. Okay, so we're doing the dot product on top, but if you want to be a real stickler, and since I've got multiple people in the room giving me a hard time about it, why do these guys not have squiggles and this one does?
Because the one's below
They are the magnitude of the vectors, yes? What can you guys remember about the dot product of two vectors? The dot product of two vectors is a scalar. Okay, it's a single number. So what you're going to end up with is a single number on top, and whilst these magnitudes are also single numbers, that's how you can resolve an angle. You get rid of your I and J components and you're just left with scalar numbers.
So say if your I component was 0,
Yeah.
your answer for the top or the numerator would just be, say if it was 0i plus 3j, your numerator would just be 3.
0i plus 3j.
'Cause
Well, it would depend on your two vectors. You've still got to do multiplication. Okay? There is a different dot product rule, but the one I'm going to show you right now is the one you want to use for this kind of question because it's a whole lot easier. Okay? We use that where, just to remind you, if you have vector A, that would be xi or x1i plus yj, and b would be 2i plus y2j. Okay, so this is one of your dot product rules. It's the easier one to use, and particularly if you have your vectors in this Cartesian form, in their position vector form, we can use that. So that's what we're going to do on top. Our magnitudes we also need to work out, and then we can solve the whole thing. So let's do our dot product A times B. What level of working out do we need to do here? I think you guys are getting it. Combined with that and this, we can probably just go for it. So my x's are going to be my 3 and my 16. Remember guys, the whole point, well not the whole point, one of the things that happens with our dot products is we lose our I and j components and we just get a scalar, so you don't need your i's anymore. This is 3 times 16, and I'm going to add that to -2 times 24.
So if you're in your rule, it's A times B, how come you're plussing?
Because that rule over
Okay, this is the dot product is what we call it.
Oh,
And to
yeah,
go
I-
back through how we got it, we do a little bit, we unpack where it comes from. For today, we're just going to go for the mechanics. Let's lock those back down, and then we can come back for that really deep understanding, okay? So dot product, this is the rule.
that?
This is the rule for it. From your formula sheet, from your textbook, just go ahead and use that.
Yeah, thank
Okay.
you.
So that's what gets us our top line. Our bottom one, we now need some magnitudes. How do we get them again?
Pythag.
Pythag. Okay, so let's just chuck all this stuff in as we go. This is going to be 3 squared minus 2 squared, and that's going to be multiplied by the square root or my other vector, which is going to be your 16 squared plus 24 squared. Anyone already got their calculators out? What's 3 16s? Yeah, what's 2 24s?
48.
Now I'm choosing to write this way again because it's the convention that we keep using, and I think it's helping you guys if you keep your thing in brackets and don't change your operators. So this becomes plus -48. Should I just stop here?
Yeah,
Why?
because that's 0.
Yeah.
0 divided by anything.
I got 0 on top, who cares what's on bottom? Yep, the rest is going to be 0. But let's write it out. You multiply that, and you could go to the effort of working all of that out. Once you've realised that your next line is a 0 on top, that's what you're going to have. Have I finished answering the question though? No, because I've still got to do this bit. So what am I going to do? I could write this back in if it helps you.
Put that in your calculator. On inverse cos.
Very good. Change side, change operation. So if you have inverse cos of 0, what's your angle?
0.
Just confirming before I make a fool of myself, it is indeed 90 degrees. So what could we say about these two vectors?
They're perpendicular.
How could we have also worked that out without even having to calculate that final angle? There's a little rule back in the day that says if you have a dot product that equals 0, vectors are perpendicular. Okay, so I know we went a step further, but as soon as you got this, 48 plus -48, yeah, that meant that your dot product was 0, so therefore your vectors were perpendicular, and there was a 90-degree angle between the two. So a cool little way there to have two different proofs or two different checks that you have in fact done the right thing. All right. Questions, comments, queries?
Where you said the dot product rule, and
Yep.
it's like where vector A is equal to x1.
Uh-huh.
Shouldn't that be y1j?
Thank you. Yep, I did write it 2 up here. So anybody who's been confused at home this whole time, you can skip forward.
Yeah,
Y1.
I was confused about that.
Sorry, yeah, that's really bad numbering on my part. That's Y1, Y2 underneath. Basically just saying that, yeah, the coefficient in front of your I and J components. Cool if I rub this off? All right, so 4 is a multi-choice. I think the easiest way for us is let's just treat it like it's not a multi-choice and try and answer what it wants from us. But before we do that, let's get some estimates. Just having a quick look at the question. Multi-choice, a unit vector perpendicular to 3i minus 4j is A, B, C, or D.
A. I'm guessing A.
Okay, we've got an A straight out of the gate. Why are you thinking A?
Because perpendicular means that you like swap them, which means that if you swap them, your -4 will become +4. I know it's D, sorry, and then because it's +3, it'll be swapped to -3.
Okay, I like what you're thinking. Your explanation's a little bit off because for a dot product, you are going to add your what's the word I'm looking for? Coefficients in front of your I, and you add the ones in front of your J. You then want them to cancel out.
I think.
Yeah, so what Britt's trying to say there is the 4 and the -3. If you add the 4 to the 3 that's in the question, you get 7. And if you've got -3 and -4 in your J components, you've got -7. 7 minus 7 gets you 0, and those two vectors would be perpendicular. Only problem is, Britt, you've fallen for the exact same trap that I did this morning when I looked at this question. What does this question actually ask you?
The unit vector.
The unit vector. It's not a unit vector. Or that particular would not be the unit vector that equals it.
What was the last question we did a unit vector?
Yeah. So we need a unit vector perpendicular to that one. So we know we're going to need to swap some things around. But let's begin with, let's just get a unit vector for 3i minus 4j.
I don't know to see.
Can anybody remember the rule for unit vector?
No.
Remembering is not the same as looking at our computers.
Unit vector.
Is it the K vector A1, sir?
That's scale.
Well, let's just go again. We divide it. How do we write this one? Let's say if this is A. Anybody remember the symbol for unit vector?
Is it? Oh, I was gonna say it's the line on top.
Not a line. Not a bar. Anyhow. Unit vector is going to equal your vector A divided by the magnitude of A.
You need a
Yeah,
squiggle.
you should have a squiggle on all the A's.
Loves his squiggles. Okay, so we know A here. And then we're going to need to divide that by its magnitude, which is going to be the square root of 3 squared minus 4 squared. 3 squared gets you 9, 4 squared gets you,
16.
add them together,
25.
25, square root of 25. So you've got 3 on 5i minus 4 on 5j. Three on 5i, 4 on 5j.
Why did you add them so?
Because when you
Because 4 squared is going to be positive 16. Square anything. So that's how Pythagoras works. Even if we have a negative j component, it squares it up and it makes it the absolute value, and we can use it that way. I felt there was something else I wanted to point out in this one, but now it is loose. Okay, so this would be one way you can work it out. Now you can apply Britt's idea. Because what is 3 divided by 5, guys? If you were to write that as a decimal. 0.6. And what's 4 on 5? 0.8. Does any of our answers have those two?
Yes, but there are reverse signs.
Exactly, which is what we want, right? The whole point is because it's perpendicular, we want the reverse sign. So let's say, what was the option for C? Sorry, what was the vector on that?
0.8i plus 0.6j.
0.8i plus 0.6j.
Yep.
That correct?
Yep.
Plus and plus.
Yeah.
Positive, 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 negative. Well, we can give it a go. I'm wondering if this all works out now. Because we're looking for perpendicular, right?
Yep.
Which means that their dot product should be 0. So let's do their dot product and find out. We're going to use this rule. x1, x2 plus y1, y2. See if we get 0. So my vector A was this guy. Plus this one. Plus my j, which in this case is negative 4 on 5. Oh, sorry, why am I doing a plus in there? That's a multiplication. And your 6, which is your 3 on 5. 12 on 25 minus 12 on 25 equals 0. Yep, so C is your correct answer. Their dot products equal 0, therefore those two things are perpendicular. Does that make sense?
Yes. Are these sort of questions going to be on our exam?
What was that, sorry?
Are these sort of questions going to be on our exam?
Well, again, and we'll probably break it down in class, but there's only so many things we do with vectors. You need to be able to add them, subtract them, just generally write them. You've got to be able to flip them head to tail, so if you're going from A to B, so remember those ones from going from the origin. So similar stuff that we were doing with our complex.
Is that just like sort of the conjugate?
Not quite the conjugate, it's like, so when we had origin, and you've got vector A, and you've got vector B, if you wanted vector A to B, you'd have to flip A so that you got them head to tail. You remember the whole head to tail thing?
Yeah.
And so that means to do A to B, what you're actually doing is vector B minus vector A, because you've taken the reverse of this, because you've flipped it around. So this is negative A, and this is B. Yep. So unlike our first question where we went east, tail, head, we turned 45, tail, head, and then we went north, tail, head. These are all good to go, and we could just straight up add them. If they'd all been coming from origin, we would have had to do more, is basically what I'm saying. So that's your easiest scenario. They're already set up for you, and you just add them. You get something like this where they're both coming from the same point of origin, then you've got to start remembering some of your other rules. All right, so a little divergent there. How are we going for time? I think we might get 1 or 2 more questions done.
3:48.
Yeah, so we're going with 5. If these two things, and it is known that A is perpendicular to B, calculate the pronumeral A. All right, so this is the first time where it's probably important all those squiggles are in there. I'm not really bitter, I'm just playing with you guys. All right, so we have vector A is equal to 3IA. No, 3I plus AJ plus AJ
Yeah,
And
it would be
vector B,
negative, 2
2AI
minus AJ.
minus AJ.
And A times B equals 0.
Okay. Something else that we know, sure, let's chuck that in there, that the dot product of A times B is 0. Dot product.
If they're perpendicular, is the dot product of A and B always 0?
Yes.
Not too difficult now, guys. We're just going to chuck that into something that we know. So I would say the easiest thing is doing your A dot B again is equal to your x1, x2 plus y1, y2, and you already know that all of that's going to equal 0. 3 times 2a is your x1, x2. Yeah, that's what's in front of your I components, 3 and 2a. You're going to add that to aj squared. Because you've got positive aj up top, you've got negative aj down bottom, it's just going to come out as being an aj squared. Or a squared j is probably the more appropriate way to write that.
Shouldn't it be negative A?
Yeah, what happens when you do plus a times negative? I guess in this case, well, yeah, we're not actually squaring. No, you're right. Thank you, Indy. Just trying to make my life a bit easier. Let's not do that. A times negative a.
And then do you put your J component outside the bracket, or just drop
Well,
it?
remember we're doing dot products, so we don't need i's and j's from here. Now that we've collected our x's and y's, we're good to go. So that's going to be 6a plus negative a squared, or the other way to think about is that 6a minus a squared. Now that you've got it from here, there's basically two ways you can go. One way that's in your textbook, and then I'll show you right now just for the sake of time, is just by a quick inspection. The other way is following your quadratic formula that I'm sure you guys have been doing in methods, right? That your b plus minus square root, that all that. Because you've now got a quadratic here, and so you can solve for your two solutions. The other way to just do it by inspection is if I took a outside of the bracket, I would have 6 minus a. And from that, hopefully you would be able to see that there are two values of a that would work here.
Would it be 3, sir?
One is if a equals 0. 0 times 6 is 0, 0 times 0, so the whole thing's going to be 0. But we're not going to be able to use that one. Because we know they're perpendicular. So a's in both, and if a was 0, having a look at your vectors, just trying to remember why, I'm having a look at them up here, okay? This would be 0, this would be 0, this would be 0, you would just have 1 with an I component. So that's not going to work for us today. What would the other solution for A be? Any ideas just by looking at
I'm
it?
thinking either 2 or 3, sir, just from a random guess, because if you expand out that bracket, your 2 times 3 or something like that is going to be 6.
Well, the way you got to think about it is this A times 6 has got to be the same as this A times that A. It's the only way it works. 6 times 6 minus 6 times 6.
Oh.
That makes sense.
Yep. So your value for A in this one is 6. Now, as I say, you guys could have gotten that through the quadratic. You would have done the exact same thing. You would have come up with the two solutions, 0 and 6, and you would have discarded 0 because it wouldn't work. And you would have found your answer to be 6. Just showing you that with this particular setup, I could probably find better words to explain it. For now, let's just leave it at that. You can get to here and you can just see that A must be 6.
Say we had one like that on our exam, and we decided to go with the quadratic way. Would we lose marks?
Not at all. No. Mr. G can tell you better than I can because he's done this before, but one of the things I got from him before I took on this class was what we've taught you in junior school about your whys and about following a set path doesn't apply as much in specialists. In this, the questions get that much harder. There's multiple roads to a solution, and what we care about is how well you can do that and then communicate it. So if you get the correct answer going through the quadratic method, absolutely fine. If you give a shortened version, as long as all your mathematical wording's there, you still get full marks. So yeah, we have a lot less prescribed, this is how it absolutely has to be.
What
You guys
about-
make my life easy if you all do the same thing. Every time I get a novel way of solving a solution, I've got to go through, double check it, make sure all your things, that's fine, that's my job. But if you follow the set paths, yeah, and you all come up with the same thing, makes life just that touch easier.
What about methods, sir? Do you still have to display your Ys?
I will not say anything about methods. I do not teach it. I am not your teacher. You have to check with them and what they are expecting.
And methods is
But I mean, for me, it's kind of stuff like in proofs, how would you do Ys? What rule are you using?
You could do your theorems, sir, but then again...
Even like some of these, we're using 3 or 4 different rules in one. And if you had to do proper Ys for each, where you wrote the rule, you identified each of its variables, you substituted them in, you then did that when you used that in your second equation, you then did that again when you subbed it all into your third, you've got a lot of working. So again, communication is important. Don't get me wrong on that. But at this level, we do not need to see WIS and E. We do not need to see that cookie cutter formula. We just need to see that you have set yourself up, as in you didn't jump straight into the working. You were like, here's what I know. Here's my vector. Here's the information from the question. Here are the variables that I do know in some way, shape, and form. And that if you are using a standard rule, that you've got that at the start of your working, if that makes sense. But again, and I'll show it in class, that dot product, we have 2 different rules, and then to calculate the angle, we actually combine those 2 different dot product rules. We would not expect you to write all 3 in order to get full marks. What are we looking at? 6.
so I still don't see how you got 6.
Out of this one, sorry, I probably should have just gone and done the quadratic. But the way that I would look at it, once you know that it's 6, is A times 6 equals a number, and A times A has to equal the exact same number, because the whole point is we're making 0 out of this. Yeah?
So, like, would it be, say it was, whatever that number is on the inside of the bracket, would it always be the same? For the
Yeah, if you have this set up, guys, it could be any number. If you've got B outside of 8, take B. B is always going to be 8. If you see this set up, you can go straight to knowing that A must be the same number. Because you think about it, what you're basically doing, if this is 6, is you're squaring that and you're squaring that, and that's how you subtract them from each other. What are we going to finish on? I think we've got a calculate angle between.
Yep.
Cool.
In radians, though, sir.
Yeah, just set your calculator to radians, guys. That's all.
I don't know how to do that.
Any radian questions on the exam, sir?
Technically, yes.
You weren't supposed to answer. Keep it cryptic.
Negative.
2J. Alright, can anybody remember an angle in between rule?
angle between, it's just wait. Is it that cos theta equals dot product?
Cos theta equals dot product over magnitudes. So again, great example that you guys were asking about, how do we need to set these up? There's your rule. I am now not asking you to write out the dot product of A and B. I would expect that you could just use your X to, maybe it's worth doing one line of that. Just to make it really clear that I know that that's the particular dot product rule that you are using. So let's start summing those in. I'm going to have 4 times -1 plus 3 times 2 all over the square root of, my A is going to be 4 squared plus 3 squared. Have you guys started to work out what this is yet, by the way?
Yeah, it's always 5 in
Yeah.
it, so.
Yeah, classic triangle. So anytime you see sides 4 and 5, you know that's going to, 4 and 3, you know that's going to become 25 and the whole thing resides to a hypotenuse of 5. So yeah, it's good to start recognising that one. And the other one's going to be -1 times -1 squared times 2 squared. Top line becomes 4 times -1 gives you -4, plus 3 times 2 gets you 6. Bottom line, so we know that one's going to be a 5, because we just discussed it. 4 squared is 16, 3 squared is 9, add them together for
Is that a
25.
plus? So in the second square root, is that a plus or a times between the negative one?
Thank you, that should be a times, you are correct.
And then the one inside the square root, is that a plus?
And that is a plus. Writing too many symbols at once, good to see you paying attention, Britt, really appreciate it. I'm sure when we did the calculations, I would have hopefully worked out I wrote those down wrong.
Would you say root 5?
This one, yeah, it's going to become root 5. Because we can't simplify that down anymore. And what we have got here, -1 squared becomes +1. 2 squared is 4, and so we end up with a root 5.
I keep thinking -1 squared is what's called I.
-4 minus 6 is going to get you 2, and then that's going to be 5 on root 5. But what don't we like? Surds on bottoms. So let's multiply this by 1, which we write as root 5 on root 5. That gets you 2 root 5 on top of 5 times 5. Gets you 2 root 5 on 25. Remember guys, we're trying to find an angle, so we're going to take the inverse cos of 2 root 5 on 25, and that's going to be our theatre.
So how did you go from
So
2 on 5 times root 5 times root 5 over root 5 to 2 root 5 over 5 times 5?
Okay, so root 5 times root 5 gets you 5. The whole point is we get rid of that square root on bottom. Okay with that concept?
Yeah.
Do they just like cancel once you have?
So the
square root
idea
times
is you have got, let's make it really easy. Square root 16
Yeah.
times the square root of 16. What's the square root of 16?
4.
What's 4 times 4?
16.
Okay, so when you multiply a square by itself, you get rid of the squared sign.
So pretty much you just get rid of the square root.
Yep.
And then
Yeah, so that's my line here. And remembering that root 5 on root 5 is 1, so I haven't changed my equation. What I've done is the root 5 comes up on top, the root disappears from down bottom, 5 times 5 gets you 25.
they want that in radians, don't they? Those,
Yeah, so make sure you need to go to your mode. I don't know this calculator well enough. I press mode twice and I can set mine to radians instead of degrees. Then if we do inverse cos
How do you do that?
of 2 times root 5 divided by 25, we get 1.3909 radians. 1.3909. If you guys want some help working out how to put your calculators into radians, I'm happy to do that.
So I just realised that the combination and permutation rules are like a...
Oh, they're there for you. Oh, that makes life easy.
Yeah, so can you tell me how to do it with radians? So I know.
Yeah, I'll do that in just a sec. I'm just going to sign off, guys, because that is 4 o'clock, so I'll shut down the video now. We made it up to, what was that, question 6 out of that review set. So in tomorrow's shoot, we'll be taking up from question 7. Yeah, sweet. Catch you next time.